Given that the acceleration a equals the second derivative of s, which is the position function, is negative 4 sine of 2t, with the initial velocity v of 0 equals t, and the initial position s of 0 equals negative 3. We want to find the position function at time t, so we're looking for s of t, where s is a function for the position. Recall that starting with the position function, if we differentiate it to get s prime of t, then we end up with the velocity. And if we were to differentiate this again, the second derivative of s, which means the first derivative of v, we end up with the acceleration t. And so given the acceleration, to get back to the position, we need to get the velocity first, one step at a time. The time we're going backward. The derivative of the position function is the velocity, and the derivative of the velocity is the acceleration. To get the position, we first need to find the velocity. V is whatever the function is, so that when we take the derivative of this unknown function, we get negative 4 sine of 2t. Think of it as going backward. The derivative of sine is cosine, and the derivative of cosine is negative sine. And so if we want the derivative of v to be negative 4 sine, we would need to make an educated guess. And our guess is perhaps negative 4 cosine of 2t, but this is not a done deal yet. We need to check. If we differentiate it v prime of t, we get negative 4 times the derivative of cosine is negative sine of 2t times 2. And so this is actually way off. We have an extra factor of 2 in here. That needs to be taken care of. And the negative times the negative is a positive, so we would need to take care of that negative as well. There are two things that we will need to update or correct in this case, meaning that our guess was not correct. So how do we fix the extra 2 and the negative? Let's try this again. V of t, we don't want the extra negative, so perhaps we start with positive 4 cosine of 2t. But remember, we got the extra factor of 2, and so how do we get rid of it? The easiest way to get rid of the extra factor of 2 is multiply 1/2. And so now v of t is 2 cosine of 2t. This is what we call guess and check for now. And then we need to check this. V prime of t is 2 times the derivative of cosine is negative sine 2t times 2. And so this is negative 4 sine of 2t, so this checks out. But based on the consequence of the mean value theorem, we see that there are infinitely many of these original functions that give rise to the same derivative. And so we would have to use v of t equal 2 cosine of 2t plus c, because the derivative of c is 0. And this is the general velocity. How do we find c? We use the initial condition, v of 0 equals 2. If we plugged in 0 into t, we replace t with 0 and rewrite everything else. This velocity is 2. 2 times cosine of 0, which is 1, plus c equal 2, and so c equals 0. We then update the equation, even though we added a plus c, but this c turned out to be 0 in this particular case. V of t is 2 cosine of 2t only. And so we took care of one step backward. Now that we have the velocity, we need to go back one more step to get the position. We make another guess here. We guess that the position s of t is 2 sine of 2t perhaps, but again, this is not a done deal. We need to check this. S prime of t is 2 times the derivative of sine of 2t is cosine of 2t times 2, and so there is an extra factor of 2 only. So how do we take care of it? S of t should be 2 sine of 2t times 1/2, or S of t is simply sine of 2t, and make sure we do a plus c. We check this. S prime of t equals cosine of 2t times 2, and the derivative of c, a constant, is 0, and so yes, this checked out. The formula or the equation for the general position function is S of t equals sine of 2t plus c, because when we checked it, it works out. We still need to find c, but to find c, we use the initial condition S of 0 equals -3. We plug in 0 into t, everything else is the same. This should give us -3. Sine of 0 is 0 plus c equals -3, and so c equals -3. The particular solution we're looking for, the position function, is S of t equals sine of 2t minus 3. How do we know that this is the correct answer? The correct answer needs to satisfy the differential equation as well as any initial condition. If we were to plug in 0 into S, we need to get -3. Sine of 0 is 0, 0 minus 3 is -3, so the initial condition checks out. We take the derivative of this to get the velocity, which is cosine of 2t times 2, and the derivative of -3 is 0. If we plugged in 0 into this velocity function, we get 2 cosine of 2 times 0. Cosine of 0 is 1, so this is 2 times 1, or 2. Another condition checks out. Next, we differentiate v to get the acceleration. The derivative of 2 cosine of 2t is 2 times negative sine of 2t times 2, which is -4 sine of 2t. And so the third condition checks out. There are 3 conditions in the given problem, and that is the differential equation, the initial condition for the velocity, and the initial condition for the position. And all of those 3 conditions checked out. The answer is S of t equals sine of 2t minus 3.